Okay, so always start, what's the base? Give 3 examples. Okay, so this is called an exponential equation. So x is the exponent and y is the result. So the 3 coordinates that I found are -1, 1/3, exponent, result, zero, 1, and 1, 3. Okay, so there's those 3 points. And it's exponential growth. Okay, so all that you did last week on Friday. Exponential growth. Whatever makes something do exponential decaying? What would cause this to go downhill instead of uphill? If the base is decimal or a fraction, like anything less than 1. Okay? Do you guys understand what's happening as you move in time? You're tripling something. You're tripling. Think about a population, right? If you have 10 people today, tomorrow, if you triple it, then you have 30. Then the next day you have 90. Then the next day you have 270. It's growing. Okay, if I had a base of 1/2, okay, and your population was 100 one day, then the next day it's 50, then 25. Okay, your population's going down. Okay, here we go. We're going to switch to a log. So we did this yesterday. We figured out all these components. So it's using 3 as a base. This is the result, and this is the exponent. So if coordinates are always written x, y, coordinates are always written x, y, the x is the result, and the y is the exponent. So what do you think I'm going to do compared to what I exponentially did? They're just going to flip. So 1/3, -1, 1, 0, and 3, 1. Okay, so exponential or log, I always start the same way. I take my base, start this. This is always. Okay, I do that no matter what, exponential or log, I do that. Now it's just, do I want to go exponent result or result exponent? Okay. Okay, so let's see what this looks like. 1/3, -1, 1, 0, 3, 1. Okay, so these are inverses of each other. Why? Because all the x and y's switched. Do you remember that inverse physically is a reflection of the diagonal? Does that look appropriate? Do you see that diagonal reflection? Okay. When you flip x and y, what can you tell me about domain and range? They switch. So let's just check this out. how would you write the domain of this? Negative infinity to positive infinity. And how would you write the range? 0 and then up. 0 with a soft, right? Because it's asymptote 0. And what's the equation of the asymptote here? Y equals 0. So what does that look comparable to the log graph? So what's the domain of this one? 0 and then right. What's the range? Down to up. And what's the asymptote? X equals 0. So do you notice stuff happening? The domain of this is the range of that. Range of that's the domain of that. Y equals X equals. Okay, everything's vice versa. Okay, here we go. Question 1. I always say, hey, what's the base of this? Which part is the base? 5. So what do? You run 5 through the cycle. So 5 to the negative 1, 0, and 1. Okay, so 5 was in the base position. X is in the result position. And Y is in the exponent position. Okay, so if we're going to write X and then Y, right, we're going to be writing it backwards. Result, comma, exponent. Okay, so it's the brain, with these logs, your brain's kind of always going backwards of your normal brain. Okay, now, that's the original, and now I've transformed two things. I have a negative here and a 2 here. Okay, what kind of letter transformation is this? The A, B, C, or D? A. So I'm going to have to do negative on the Y values. And then this is a C. So I'm going to add 2, right? Everything with C's and B's is opposite. Okay, so there I go. I'm going to add 2 to everything on the X. So 1, nope, just kidding, 2 and a 5th, 3 and 7. Positive 1, 0, negative 1. Okay, so here I go. 2 and a 5th, comma 1. 3, comma 0. And sorry, this is a little bit off the map here, but 7, negative 1. Okay, so there's an asymptote at 2. Why? Because this is a shift to the right 2. So we have an asymptote, now it's moved 2 over. Okay, do you remember something that I talked about yesterday? I said whatever you're doing as a log, your result has to be positive. Okay? What is your domain if you want this value to be positive? If you want this to be positive, you can't be 0, you can't be negative. You have to be positive. What kind of x value do you need to be?
Maybe decimals.
Yeah, as long as it's a positive decimal. What's my domain if I want to be positive? Oh, I have to be over 2, right? Bigger than 2. So you can go like this, 2 to infinity or over 2. Okay, look at my graph. What's the domain of my graph? Over 2. You're to the right of 2. Okay? So does that make sense with what I said yesterday now? This always has to be positive. And then that matches the graph. Okay, a log. Okay, so when working with logs yesterday, we always were following this format: log base result equals exponent. Okay, so what is the base? 10, remembered. The base is 10, it's that secret one, because there's nothing down here. Okay, so this is the secret one, 10. Okay, so what do? 10 to the negative 1, 10 to the 0, 10 to the 1. Okay, so since this is a log, how should I write my coordinate? I should write it as a result, comma, exponent. The opposite of your brain. Usually in math in all the past, you get the exponent and then figure out the result. Okay, logs are doing the opposite. We have the result. And then at the end, we figure out the exponent. So we have the result, and then we figure out the exponent. That's what a log does, right? Okay, so this is the original stuff, but we're going to transform these original points with 2 things. There's a negative thing and there's a 4 thing. What kind of transformation letters are they? B and C. There is a red flag problem going on right now. Anybody note it? Not factored out. How many of you forgot to do that on your last test when you graphed something? Lots of you. Factored out. I caught lots of you. I'm going to rewrite this then. I'm going to factor the negative out. And then it's going to be okay, so there's the B and there's the C. Remember, divide by B, subtract C. Opposite, opposite. Everything B and C is opposite math. Okay, here we go. negative 1/10, negative 1/10 plus 4. Negative 1/10, and then you add 4. Okay, negative 1 plus 4. Negative 1 plus 4. And then this would be negative 10 plus 4. Okay, so where is the asymptote as well? Where should the asymptote be located? What x value? A positive 4, because it's shifted. How did it shift? Right 4. Okay, last question. Okay, so this is the one that you had to skip in your homework because we hadn't seen it yet. So ln is called the natural log. So all you French immersions, I always say the log au naturel because it's ln, the natural log. Okay, so ln is the natural log. It is the same thing as this, log e. Has anybody ever seen an e in math with science? Okay, so that's new. Okay, you can explore your calculator. You have a button called an e button. So e, so in math, if you guys ever say pi, there's a value of pi, right? 3.14 da da da. Okay? E is the same kind of idea. E has a value. Can anybody see if they can discover the number value for what E is? It's kind of like a pi. Pi is 3.14 about. Okay, so my calculator, when I push my E button, it makes me do an exponent. So if I just do e to the 1, mine makes me do an exponent. Okay, so this value is a number that scientists use all the time for bacterial growth and things like that. Okay, so here I go. Base, it's always what I ask myself, no matter what. Exponents, logs, I always say, what is the base? So the base is an e. So e to the negative 1, e to the 0, e to the 1. Okay, so we know this because anything to the 0 is 1. And you should have just done this in your calculator. E was 2.7. Okay? You know how I always make you round to 3 decimal places? You know what? On a graph, am I going to tell? No. I'm not going to figure out if you're doing 3 decimals on your graph, okay? So I'm just going to go that. This is a calculator. You would use your calculator.
You said we couldn't use it on the exam.
You get your calculator for 75 minutes. No, 45 minutes. So this could be on that. I mean...
How do you know? Is there like a calculator section?
Yeah.
Like we have to dig through it and see what
No. It's the first booklet is your calculator, and then your second booklet is no. There's usually 45 to 50 questions. Okay, did anybody get this one? 0.36. Can I just do 0.4 because it's a graph? It's a graph, so I'm not going to know. Okay, this is a log. So how should I write my coordinate? -1, 0.4, or 0.4 and then the -1? 0.4 and then the -1. Because logs, you always are figuring out the exponent. Result, comma, exponent. Okay, so that backwards brain stuff yesterday, we're always getting to the exponent at the end. Okay. What kind of letters do I have? A and C. A and C. So 2.4, 3, and 4.7. Add 2, add 2, add 2. Okay, so graph those points. Where is your asymptote? At 2, x equals 2.